This is Mrs. Fraser with solving equations with variables on both sides. So we are going to look at some steps to follow when solving equations with variables on both sides. Just remember that steps don't always have to be followed. There might be a step that doesn't always occur, but these will just be a guideline for us as we are solving equations. So the first step we're going to look at is combine like terms on each side. Okay, so I want to combine like terms on each side of my equation. So when I'm talking sides, I'm talking on each side of my equal sign. So often people like to draw a line so that we can divide into two sides. Let me make that a little straighter. So that can help us look to see if we have like terms on each side. So looking on my left, I'm going to circle each of my terms. So I have 5x, and then I have -3. And notice that I put my -3 in the box with it, because that reminds me that this, even though it is subtraction 3, that this would represent a -3 if I were to model this with my models. And then on my left side, I have 2x and +6. So now I'm looking on each side to see if there's anything I need to combine on each side. Well, I have nothing I need to combine on my left side, and nothing I can combine on my right side because these are not like terms. If they were, then I would have the same symbols drawn around them. They'd both be x's or they'd both be constants. So I'm not going to need to combine my this time. So the next step I'm going to do is if there are variables on both sides, I'm going to get the variable on one side. Okay, so looking at my equation, I want to get my variable on one side of my equation. So to do that, I'm going to go ahead and add the opposite. So I'm going to add -2x to a +2x. And I'm going to add a -2x to my 5x. To help me make sure that I am adding it to the right place, I can circle it again because I know that I can't put this x with my constant. Okay, so I'm making sure that I'm keeping my variables together and I'm keeping my constants together. Okay, after I subtract my 2x from both sides, on my left side I'll be left with 3x minus 3, and on my right side, 2x and -2x made 0, so I'm only left with +6. So just to help myself, I'm going to go ahead and remark my terms. So I have 3x and -3 and 6. So now my next step, my step 3, is to get the constant on one side. So you can see I have -3 and 6. 6 is already by itself. So I'm going to add 3 to both sides. By adding a +3 for -3, I get 0. And I'm left with 3x equals 6 plus 3, which makes 9. Just to double check that I didn't make any mistakes, I'm going to box in that positive 3 so I know that I combined a constant with a constant. So my next step in solving is to eliminate my coefficient by multiplying or dividing. So I'm going to multiply or divide by the coefficient. So the whole purpose of this is I don't want 3x's, I want 1x. So 3 divided by 3 gives me 1. So I'll be left with 1x, which I can just write as x. And then to balance, I'm going to do 9 divided by 3, which gives me x equals 3. The very last step that I'm going to take is I am going to check my solution. So I'm going to go back to my original equation, 5x minus 3 equals 2x plus 6. And in my calculator, I'm going to type in 5 times 3 minus 3 equals 2 times 3 plus 6, just like that. And in my calculator, once I type that in, I should get true. Okay, we're going to go through our other three. But before going through them, I'd like for you to pause the video for each one and try it for yourself before you go through, and then come back to the video and check. Okay, so I have 7x equals 2x minus 25. So remember, our first step is to combine like terms. So I'm going to go ahead and circle my terms. I'm going to circle my x's, and I'm going to put a box around my constants, just so I can have them as symbols. So if I look on each side of my equation here, I can see that I don't have anything I combine on my left side and anything I can combine on my right side. So my next step is to get the variable on one side. Since 7x is already on one side by itself, I'm going to go ahead and do minus 2x or plus negative 2x. So I'm adding negative 2x on both sides. So by adding the opposite, I'll get 0. Now I have 5x equals negative 25. Again, I'm going to go back and check and make sure that I can really subtract a negative 2x from the 7x. So I'm checking my symbols. Okay, I know that if this was a constant, I could not add it with a variable. So far we are correct. So the next step is to get the constant on one side, except my constant is already on one side. So I don't need to go through that step. And step 4 is to multiply or divide by my coefficient. So my coefficient is 5. So I'm going to divide both sides by 5. And I end up with x equals negative 5. And finally, we're going to check our solution. So we'll have 7 times 5 equals, times negative 5 equals 2 times negative 5 minus 25. And in my calculator, if I type it in just like that, I should get a true statement. Okay, number 3. So number 3, again, starting with our first step. Our first step is to combine like terms on each side. So I'm going to circle all my variables. Notice I'm keeping the sign with my variable so I can know if it's positive or negative. And I'm putting a box around each of my constants. So now if I look at one side at a time, I can see on my left side, I can combine 2x and 4x. And that's going to make 6x. And so I have 6x plus 4. And on my right side, I still have 25 minus x. So I'm going to circle my variables again and box in my constants. My next step is to get my variable on one side. So I'm going to add the opposite. So I'm adding positive x to a negative x, which will give me 0. And I'm adding a positive x to a 6x, which will give me 7x. So now I have 7x plus 4 equals 25. And I want to make sure I added those x's to the right places. So I'm going to go back and I'm going to circle to make sure my symbols are in the right place. Okay, my next step is to get my constant on one side. So I already can see that 25 is already on one side by itself. But the 4 isn't, so I'm going to add a negative 4. So I added my constant to my constant, keeping my like terms together. And I'll be left with 7x equals 21. And finally, my last step is to divide by the coefficient. So I have x equals 3. And of course, we're going to go back and check. So I'll plug my 3 in every time I see x. 2 times 3 plus 4 plus 4 times 3 equals 25 minus 3. And again, we should get a true statement and my calculator for this. Okay, my last example. Then I am going to go through and I'm going to circle my terms. So I have half x and negative 4x. I have 3 and 2/5. I can see if I look on my left side, there is no like terms to combine. And on my right side, there's no like terms to combine. So that is step 1, so I don't need to combine like terms. Step 2 is to get my variable on one side. So I can see that I have a negative 4x and a positive half x. So I'm going to add a 4x to the right side, which will make 0. And I'll add 4x to the left side. So I have 4.5x, or if you'd like to, we can write 4.5x plus 3. And on my right side, I have 2/5, or if you would like to change that to a decimal as well, I have 0.4. Okay, so I'm going to go ahead and circle my variable and put boxes around my constant. So my next step is to get my constant onto one side. So I'm going to do that by subtracting 3 or adding a negative 3. So I'll have 4.5x equals negative 2.6. And my last step is to divide by my coefficient. So I'm going to divide both sides by 4.5. Okay, and my answer is approximately 0.57 repeating. So x equals 5.57 repeating. This one might be a hard one to check your solution to, being that it's a 0.57 repeating. So I won't actually get a true statement in my calculator. So that's not a wonderful one to try for that. But you still can plug it in and check and see if your answers get close. But we can't actually get a true statement in my calculator for that one. Okay, so your job now is to go and complete the game in class. Remember to turn in your paper to receive credit for your work today. This paper, though, is your notes, so please put this paper in your math folder.